All right, so this is video 2 for chapter 16, but video 2 for module 5. So this chapter is about carboxylic acids and esters. Like I said in the first video, I'm cutting esters, so this is just about carboxylic acids. So just a reminder of what carboxylic acids look like. It's actually this interesting combo of functional groups. It's a combo between an aldehyde. So it's a combo between an aldehyde and an alcohol. So it has a carbon double bonded to an oxygen, also bonded to an alcohol or an OH group. All right, so in red here, these are carboxylic acids. It will also always fall on a terminal carbon. All right. So let's talk a little bit about the properties. So a carboxylic acid has the ability to hydrogen bond in lots of different places. And again, I know that this might not make a whole lot of sense to you. I promise that hydrogen bonding is not on the exam, so don't have to worry about that part. But it's very soluble, and it has a high melting point and high boiling point. Carboxylic acids, potentially, I'd have to double check a look, but they are the most soluble functional group and the highest melting point and boiling points. Don't quote me on that. If they're not the highest, they're close. All right, so how the heck do we name them? Come on. So carboxylic acids, same naming conventions. We want to make the carboxylic acid the star of the show. His suffix, if a carboxylic acid is present, is anoic acid. All right. So I could name this or number this 1, 2, 3, or 1, 2, 3. I'm gonna always want to make the carboxylic acid the star of the show. So I'm gonna use numbering right to left. And I know I'm gonna have the ending anoic acid. Because it's a 3-carbon chain, it's gonna have the parent prefix of prop. So this is propanoic acid. Now, here's another one where I don't have to tell the audience what carbon it's coming off of, because it will always land on a terminal carbon. That's the characteristic of the functional group. So don't have to tell the audience. Carbon, because carboxylic acids will always be on carbon 1. All right. So if there was a branch coming off of this, I would need to take care of that, name that, but this example doesn't have a branch. So this structure is named propanoic acid, and that is all. All right. So here is where we deal, I mentioned in the first video talking about benzene rings. Here is where those benzene rings come into play. So sometimes benzene rings can be attached to other functional groups. It's common for a benzene ring to be attached to an carboxylic acid group. And it's so common that they ended up giving it its own suffix. So it becomes benzoic acid. We actually don't have to worry about any parent structures names here because the parent chain is the benz part. We just need to tell the audience what groups come off of it. So one other thing here. So a benzene ring is a 6-membered ring with every other bond being a double bond. This is a benzene ring. Sometimes the shorthand is just putting a circle in the middle. So this circle in the middle is synonymous with a double bond every other. All right, so I'm going to erase that so I have room to write. Okay. So now it's a matter of figuring out how to number it. So my number 1 is always going to be where that carboxylic acid group is. So here's the carboxylic acid group. Now it's a matter of determining if I should go clockwise or counterclockwise, and that depends on what branches are coming off of it. So there's only one branch coming off of it. If I were to go clockwise, that would put that branch at the next lowest possible position it could be. Whereas if I were to go counterclockwise, well, here, let's just show you. If I go clockwise, I put the branch at 3. If I go counterclockwise, sorry, that's over so far on my iPad, I can't reach it. If I go counterclockwise, I put the carbon at 5. So it's more desirable to go clockwise. So all right, so we're going to go clockwise. We know that it's going to be benzoic acid because there's a carboxylic acid group connected to a benzene ring. And now we just need to name this prefix just like we do any other branches. And so I'm going to say what carbon it's coming off of, and it's a 1-carbon chain, so that's a methyl group. So this is 3-methyl benzoic acid. When you go to type this into OWL, it's going to want 3-methyl, no space, benzoic, space, acid. Now, if you, again, your final is multiple choice, but if you were to put a space here, people would know what you meant. The scientific community would know. But OWL likes to be difficult. All right. So let's move on to our next slide here. Here's an example from your OWL of naming carboxylic acids. So I threw in this 3D structure one. If you are like the last group, you probably are going to hate the 3D structure ones, but I can't take them out. So we will learn to work with them. When you deal with these 3D structure ones, the first thing you want to do is orient it so it makes sense to you. So you can grab this molecule and orient it with your mouse, or if you have a touch screen, and it's kind of like, I think you click and hold and then move the mouse around and it will move the molecule. So for the purpose of the screenshot, I have already oriented it how I wanted to show you. So here we have a C. This is an O, and this is an OH group. So right here is my carboxylic acid group. Here's a C, 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 C. So this guy, if I were to interpret it, it looks like we have a carbon here, here. This is the carbon, which is the carboxylic acid group. Then we have a methyl group coming off of here and here. All right, so do we see this? I wish I had a laser pointer. So do we see how I got that? I guess you guys can't answer me. Hopefully you see how I got that. So now I want to figure out how I'm going to number this. I've identified that it's a carboxylic acid. So I want to figure out how I'm going to number it. With carboxylic acids, I always want to put the carboxylic acid carbon at number 1. So in this case, I'm going from right to left. So I know that my ending is going to be anoic acid, since we're dealing with a carboxylic acid group. It's going to be butanoic acid, because there's 4 carbons in the parent chain. And so now I need to deal with these methyl groups. So there's a methyl group coming off of carbon 2 and a methyl group coming off of carbon 3. And don't forget, whenever we have 2 of the same group, no matter if they are coming off of different carbons, we put di or tri or whatever prefix we need to depict how many groups there are. So there's 2 methyl groups, they're coming off of different carbons, but I still call it dimethyl. That's the one rule that just makes 0 sense. Well, there's a lot of rules in the naming that make 0 sense to me, but that one really makes 0 sense to me. All right. So next, I want to talk about reactions with carboxylic acids. So basically, I want to talk about saponification. So this is the process in which soap is formed. It's a special kind of reaction, right? So we take an ester or carboxylic acid, we react it with a base. Hope you remember base from week 3. So usually NaOH, and we get back a carboxylic salt. I don't need you to know what carboxylic salt is. I want you to know that saponification is a reaction between an ester and a base, or a carboxylic acid and a base. Okay. All right, and that brings us into the next video.